Welcome to MyProjectBazaar.com. Let me discuss about the project Successive Interference Mitigation in Multi-User MIMO Channels. Let me discuss about the abstract of the project. Mitigation of interference for multi-cell multi-user in multi-input single output interference network is designed. In this proposed system, messages are splitting into private message and common message. In order to maximize the sum rate and minimal rate, covariances of private message and common messages are estimated. Successive decoding algorithm proposed for decoding both private and common messages. The optimization problems will solved by implementing the difference of concave functions. Developing an efficient DC optimization framework which is implemented over the disconnected region of split private and common rates in multi-user MIMO ins for minimizing the sum rate and minimal users rate. And Kobayashi rate splitting scheme is viewed as the best strategy to cancel the interference and improve the performance. Accordingly, DC iterations are derived to locate its optimized solutions. DCI algorithm provided to improve the rate performance at each iteration. The Han-Kobayashi strategy yields the best inner bound on the capacity region. The network optimization problem consists of jointly determining the appropriate users in adjacent cells for rate splitting, the optimal transmit beamformers for common and private messages, and the optimal common private rates to maximize the minimum achievable rate across the users. This message splitting algorithm implemented for both MIMO and MISO interference networks. Let me discuss about the flow diagram for our process. In the transmitter and receiver antenna deployment, each cell has one base station equipped with NT antennas that serves its K mobile users, each of which is equipped with NR antennas. User J in the ith cell is referred to as user I, J. Transmit precoding is implemented at the base station to separate signals from user within each cell. Thus, interference mitigation needs only occur between users belonging to different cells. Next, in the generate private message and common message for user, in this approach is concerned with joint pre-coding and common message decoding approach to mitigate intercell interference. Introduce a pairing operator A of I, J that describes with other user beside user I, J, decodes the common message of user I, J. When the user I, J has no common message, let A of I, J be the empty set. Next, in the decode private message and decode the common message by own receivers and decode the common message by other users. The system adopted a two-stage scheme where each receiver jointly decodes the two common message in the first stage and then decodes the private message in the second stage. Therefore, its achievable capacity region should lie in between that achievable by the joint decoding and the successive decoding as employed in the current paper. The computational solution is based on non-convex optimization in covariance matrices over sample power factors. Its computation implementation with 225 uniformly sampled points consumed. Next, in the beamforming solution, the system focuses on a direct formulation involving the original beamforming variable W only. Pairing parameter is also chosen as in the previous section. This based on the solution of the conventional coordinated beamforming. Next, in the sum rate estimation and estimation of minimal rate. The form of these optimal power splits by the DCI is consistent with the conjecture that for two user symmetric ions, the maximal sum rate is achieved either using symmetric power splits or by constraining one of the users to send a common message only. At PB is equal to 50 dB, the gap between joint decoding and successive decoding is 1.01 bit per second per hertz, which is the same as its counterpart. Next, in this process will be repeated for SISO, MISO and MIMO application, and this simulation will be repeated for Monte Carlo simulation, that is maximum iteration will be reached. Let me discuss about the running procedure for our process. Select the normal.m file in the current folder, right click the file and run for executing this process. Here we perform the successive pre-coding algorithm and also message splitting scheme for MIMO networks, and we got the output for sum rate and as well as minimal rate. Let us see one by one. This is the symmetric graph for sum rate versus private message, that is power to noise ratio for joint pre-coding and also successive pre-coding algorithm, and this is the rate performance for the variant for PB is equal to 0 dB. Here we obtain the sum rate and also minimal rate for various schemes, and this is the rate region and achievable rates for PB is equal to 0 dB for various conventional scheme, and this is the rate performance for the variant PB is equal to 90 dB. Here we obtain the sum rate and also minimal rate for various conventional schemes, and this is the rate region and achievable rate for PB is equal to 90 dB for various conventional schemes, and here we obtain the sum rate versus number of antennas between new scheme and also conventional scheme, and here we also got the sum rate versus number of antennas for PB is equal to 30 dB. Here green line represents the upper bound and black dotted line represents the two-stage scheme. We got the output for sum rate of new scheme and also conventional scheme, and this is the rate performance versus interfering channel strength for Monte Carlo simulation 2 for sum rate performance, and this is the rate performance versus interfering channel strength Monte Carlo simulation 2 for minimal rates, and this is the graph for rate performance versus interfering channel strength Monte Carlo simulation 3 for sum rates, and this is the Monte Carlo simulation 3 for minimal rates graph, and this is the Monte Carlo simulation 4 for sum rates of interfering channel strength versus rate performance, and this is the rate performance versus interfering channel strength Monte Carlo simulation 4 for minimal rates between new scheme and conventional scheme, and this is a typical DCI convergence pattern between new scheme and also conventional scheme, and this is the beam forming rate performance versus interfering channel strength for 4 user, and also here we plotted the graph for sum rates between new scheme and also conventional scheme, and this is the same beam forming rate performance graph for 4 users in the case of minimal rate between new scheme and conventional scheme, and this is the beam forming rate performance versus BS, that is base station power for network minimal rates between new scheme and also conventional scheme, and this is the beam forming rate performance versus base station power for network for sum rates between new scheme and also conventional scheme. Proposed message splitting schemes for both MIMO MISO interference networks outperform other existing methods and converge within relatively small number of iteration. Thank you.